Hi everyone, in last video we have gone through few problems regarding this KVL and KCL, and in this video also we are going to discuss another problem. See here, firstly you have this circuit, right? Just give a name so that it will be easier while identifying this applying KVL and KCL in each of the loop. Okay, let us suppose this to be A, this is B, this is C, D, E and then F. And let us suppose the current flowing, see here, as if you can see this here, it is a node or junction. Since three elements were involved here, that is three resistors, 5 ohm, 3 ohm and 8 ohm, right? Here current division takes place since it is a junction. Now let us suppose the current flowing like this, that is towards this junction B as I, and this current to be I1. Now let us suppose this is moving in this direction. Firstly, I have explained you in last video that we can we can take any direction of this current. So I am assuming this direction. So let us suppose it is I, it is I1. Now since we assume this also moving away from the node, right? So what we know according to KCL, sum of the currents entering the junction is equal to sum of the current leaving the junction. Now initially we don't know this current that is going through this 8 ohm, right? So let us suppose it to be X. Now the current entering this node, see, I'll draw this here. See, this is your node B. Let us suppose this is a current I and this is I1 which is leaving the junction, and this is also leaving the junction. Since we don't know this, assume it as X. Now sum of the current entering, which is I, is equal to I1, that is leaving, and X, which is also leaving. Now here we'll get the value of X as I minus I1. That means the current through this 8 ohm resistor is I minus I1. So in that way we'll calculate. And now let us suppose the current through this 10 volt battery is I2. Okay, and again by using the same concept here, see here, your I minus I1 is towards this node C, and this I2 is also towards this node C, and let us suppose this current to be X. Now sum of the currents entering the junction, that is I minus I1 plus I2, which should be equal to the sum of the current leaving the junction. So this current will be I minus I1 plus I2. Okay, see, these currents are said to be branch currents, okay, which are flowing through each source. So now as we have find out this current, it is easier to write now this KVL and we can solve. Okay, now coming to this loop A, B, F, A. So here we are applying KVL to this A, B, F, A, right? Let us suppose we start from here. As in previous video we have discussed sign convention, that is if we move from positive to negative we should get negative sign, right? What is this KVL refers to? Voltages should be equal to 0, right? That is sum of your voltages in a loop should be equal to 0. Since your current always flows from positive to negative, that means here you are moving from positive to negative, and we know that voltage V is equal to IR, right? So as we are moving from positive to negative, it should be minus 5 into I, as V is equal to IR. And now in this direction, see, your I1 is like this. It means your current always flows from positive to negative. Again, since you are moving from positive to negative, here also your voltage will be negative, that is minus 3I. And now if we see this terminal which is short is considered to be negative, and this long one is considered to be positive. Now as here we are moving from negative to positive, it will be plus 5 volt. Okay, now applying KVL to this we'll get this equation, that is minus 5I minus 3I1 plus 5 equal to 0. Hope you have understood. And now applying KVL to this loop, that is B, C, E, F, B. Okay, here we know that the current is I minus I1, right? Either you can start from here, anyhow as your wish. See, as we are moving from here, your current always moves from positive to negative, right? So it will be again minus 8 into I minus I1, that is V is equal to IR, right? So your I is nothing but I minus I1 and R is 8 ohm. And here we are moving from positive to negative again, so it should be minus 15. And since here this short one is considered to be negative and this long one is considered to be positive terminal, right? So since we are moving from negative to positive, it is positive, that is plus 10. And again see the current which is flowing here, here also the same current will flow, but the direction will be opposite. Remember this one, since here your current is I minus I1, here it will be I minus I1 in this direction. If it is in upward, if it is in this direction, in downward it will be in this direction. Okay, now as again our current moves from positive to negative, see I have explained about sign convention in detail in the previous video. Minus 9 into I minus I1, and then since your current is in this direction, that is current is always from positive to negative, but here you are moving from negative to positive, right? So it is positive, that is plus 3 I1 is equal to 0. Now we have also applied KVL to this equation, and on simplifying this equation you will get like this. So let us consider these to be your equation 2. And now again here we have another loop, right? That is CDEC. CDEC. Now you are applying KVL to this loop. See, don't confuse this. This is a 10 ohm resistor. Okay. For suppose now let us start from here. Let us start from here. Since we are moving from positive to negative, we'll get negative, right? So minus 10 volt. And here again this current direction is like this. Again, since we are moving from positive to negative, here also through this 4 ohm resistor the current flowing is nothing but I2, right? And again since we are moving from positive to negative, you will get minus 4 I2, that is minus 4 I2. Since we are moving from positive to negative, minus 10 minus 4 I2, and here your current is I minus I1 plus I2, right? And as you are moving from positive to negative, again it will also be negative, that is minus 10, that is V is equal to IR, right? Here your I is I minus I1 plus I2 multiplied by this resistance. And again like this coming to here, here also since we are moving from positive to negative, you will get minus 6 into I minus I1 plus I2 is equal to 0. And again by simplifying this you will get one equation, right? And by solving these three equations we can easily find the values of I1 and then I2. And the moment we find the value of I1 and I2, we can easily find this current, voltage and power in all these elements. See, now in order to solve this equation, either you can solve by substitution method or else by using this matrices, and also with the help of a calculator. See here, if you go to mod setup and if you click 5, and our equation is in this form, so go to this 2. And now since our three equations, or wait, I'll write these three equations at a place. See, now this is your equation 1, this is your equation 2, and this is your equation 3. And in order to calculate this by using calculator, see here, firstly you have I1 and I2, right? Now the coefficient of I is nothing but minus 5, so you have to place minus 5 and press equal to, okay? And after that you have I1, that is minus 3, so place this minus 3 and equal to. And here you don't have I2 term, so place it as 0 and then again click equal to. And here this it is in the form of Ax is equal to B, right? So at last you have to place this value of B, which is nothing but minus 5, and again click equal to. And now here the coefficient of I is minus 17 equal to 20 equal to, here again your I2 is 0, right? So 0 equal to 5 equal to, and then again here minus 16, so minus 16 which is equal to 16 which is equal to minus 20 which is equal to 10. And the moment you click equal to, oh my god, here you get the value of x, which is nothing but 0.562. That means firstly, as here the equation in the form we have taken as I1 I2, right? So the first value is your I, which is nothing but your I is equal to 0.562. This is what we got, I is equal to 0.562. And the moment you click equal to, again you will get the value of y, and if you place this as is equal to d, we will get in decimal. So your y value is 0.728. See, your I1 value is 0.728, and the moment again you click equal to, you will get z is equal to minus 0.36. Okay, that means your I2 is equal to minus 0.36. In such way, we will calculate these values of I1 and then I2. I hope that till now you have understood what we are discussing about. And now here our goal is to calculate this current, voltage and power, right? See, since here we have assumed like random directions, right? That is I minus I1. See, now if you make I minus I1 and if it gives you the negative result, then you have to know one thing, that our assumed direction is incorrect. That means our direction should be opposite. It means previously we have taken I minus I1 in this direction, right? But since this is negative, we have to take the direction of I minus I1 opposite to the previous one. See, in such way. Initially we have considered this I minus I1 plus I2 direction as like this, no? But if you make this I minus I1 plus I2, you will get negative sign. So again our direction is incorrect, and we have to make opposite direction to it. Since previously we have assumed in this way, this should be like this again, and we have assumed I2 in such way only, and it is also positive, so it remains in the same direction. Hope you have understood how we identify the directions. Now we have to calculate current, voltage and power in all elements, right? In this 5-volt battery, the current flowing is I. So you have to place the value of I, which is 0.562, and the voltage is 5, and we know that power is equal to voltage into I. And in a similar way, the current flowing through this 5 ohm is 0.562. In such way, we'll calculate this IVP for each element. Hope you can calculate this. Thank you for watching, and subscribe my channel for more videos. And if you have any doubts regarding this topic, you can ask me in comment section, and I'll definitely respond to each of your comments. Thank you for watching.